Gosh, Pocket Ronnie made me enjoy eating triangles. So welcome back.
Okay, today we're going to be doing trigonometric functions. For short, I just like to say trig functions. That is short for trigonometric or trigonometry, trig functions. Trig functions can only be used with right triangles, so we're going to look at this right triangle to start with. So again, trig functions can only be used with right triangles. So in a right triangle, remember this is the 90 degree, the right angle. Across from the 90 degrees is the hypotenuse. This side over here, across from the 90 degrees, is the hypotenuse always. The hypotenuse will always be across from the right angle. The other sides of the triangle, these legs, we're going to have names for them, opposite and adjacent, but it's all relative to where you are standing. If I am this little man standing right here, then this side would be opposite, and this side right next to me would be the adjacent side. If I was this little man standing at this angle right here, then this side would be opposite, and this side right next to me would be the adjacent side. So the opposite and adjacent side in a right triangle are all relative to where you are standing, which angle you are standing at. Okay, so in our triangles, we're going to be calling angles theta and alpha. These are Greek letters in the alphabet. So we're going to be using these Greek letters theta and alpha for our angles. Our three main trig functions are sine. This is the long word for it. You will see it abbreviated as sine. If you have a scientific notation, you will see these three trig functions on your calculator. Cosine, the whole word, will be abbreviated cosine, C-O-S. Again, this is sine on your calculator, not sin. Then you also have tangent, which will be abbreviated T-A-N, meaning tangent. The definition of sine is opposite over hypotenuse. Sine, cosine, and tangent will be a ratio. Ratio is a fancy word for fraction. So the definition of sine, making a ratio or a fraction out of it, is the opposite from where you are at over the hypotenuse. The definition of cosine is the adjacent side over the hypotenuse. And the definition for tangent is the opposite side over adjacent. So we use these three letters, A, O, and H, to stand for opposite, adjacent, and hypotenuse. There is a word, not a word, it sounds like an Indian chant, SOHCAHTOA. This stands for sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. This helps you remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So if you can remember this acronym of SOHCAHTOA, it'll help you remember the definitions of sine, cosine, and tangent. Sine, cosine, and tangents have a lot of real-world applications. So let's just practice using our definitions to determine ratios, fractions of our trig functions. Let's look at problem 29C, 1 through 6. We have a right triangle. Again, trig functions are only used for right triangles. So this angle here is labeled theta, this angle here is alpha. So we have our hypotenuse is 50, and then the other two legs are 40 and 30. Number 1, 2, and 3, we are wanting to know sine, cosine, and tangent of theta. So first off, we need to stand at theta because it's all relative of where you're standing. So if we stand at theta, remember sine theta, sine is opposite over hypotenuse. So if I'm standing at theta, the side opposite of me is 30. So the opposite side is 30. Hypotenuse is always the same. It's always across from the 90 degrees. So 50 over 50. Always reduce your fractions. Always, always. So 30 over 50 can be reduced by 10 to be 3/5. So therefore sine theta is 3/5. Now look at cosine theta. We're still standing at theta, but cosine, the definition of cosine is adjacent over hypotenuse. So if I'm standing at theta, the side adjacent or next to me is the 40. So that would be 40 over the hypotenuse, which is still 50. Reduce our fractions, those both can be reduced by 10. So cosine theta is 4/5. By the way, this is the answer for that. That's the answer for that. Tangent theta, we're still standing at theta. The definition of tangent is opposite over adjacent. If I'm standing at theta, the side that is opposite of me is the 30. And the side that is adjacent to me or next to me is the 40. Again, reducing my fractions by 10 will be 3/4. Now if you look at 4, 5, and 6, I now want sine, cosine, and tangent for alpha, which means I'm no longer standing at theta anymore. I need to go stand at alpha because it's relative of which angle you're standing at. So I'm standing at alpha. So sine of alpha, the definition of sine, same definition, opposite over hypotenuse. But if I'm standing at alpha, the side that is opposite of me is 40. And my hypotenuse is still the same. The hypotenuse doesn't ever change. It's 50. So reducing my numbers by 10 will be 4/5. Now cosine of alpha. Cosine, the definition of cosine is adjacent over hypotenuse. If I'm standing at alpha, the side that is adjacent to me or next to me is 30. And then the hypotenuse doesn't change, so it's 50. I can reduce these both by 10. Then tangent alpha, the definition of tangent is opposite over adjacent. If I'm standing at alpha, the side that is opposite of me is 40. And the side that is adjacent to me is the 30. Reducing those both by 10, I get 4/3. For trig functions, leave your fractions in improper fractions. Like here, leave it as an improper fraction. Do not change it to a mixed number. Okay, now we're going to do trig ratios where we have radicals in our ratio. We're looking at 29b, 7 through 12. The first three, we want to do sine, cosine, and tangent of theta, which means we will be standing at theta. And so sine of theta, remember sine is opposite over hypotenuse. If I'm standing right here, the side that's opposite of me is 13. And then my hypotenuse is always across from my right angle, which is 26. 13 over 26 will reduce. Make sure to reduce your fractions. And so that is 1/2. So sine theta is 1/2. Cosine theta, the definition of cosine is adjacent over hypotenuse. If I'm standing right here at theta, the side that is adjacent or next to me is 13 square root of 3. So 13 square root of 3 over the hypotenuse. The hypotenuse is 26 still. That doesn't change. In rules of radicals, whole numbers to whole numbers, radicals to radicals when dividing, and I can reduce my 13/26. So that would be square root of 3 over 2. Because this, reducing them both by 13, that becomes 1, and that becomes 2. So it's basically 1 square root of 3 over 2. I just don't have to write my 1 there. Tangent of theta. Tangent is opposite over adjacent. If I'm standing at theta, the side opposite of me is 13. And the side that is adjacent to me or next to me is 13 square root of 3. 13 square root of 3. Remember, you cannot leave radicals in the denominator. That is a no-no, so you have to get rid of the radical in the denominator. To get rid of that radical in the denominator, you multiply by square root of 3. So the numerator becomes 13 square root of 3 over 13. This would be 13 times the square root of 9. Square root of 9 is just 3, so that's 13 times 3, which is 39. That can be reduced. So they can both be reduced by 13. Reducing that by 13 leaves a 1. Reducing that by 13 leaves a 3. So this becomes square root of 3 over 3. So the tangent of theta is square root of 3 over 3. Here are my final answers for this. Okay, now let's look at sine and cosine and tangent of alpha, which means I'm no longer standing at theta, I need to stand at alpha. So everything is now relative according to standing at alpha. Remember, sine, definition of sine is opposite over hypotenuse. If I'm standing at alpha, the side opposite of me is 13 square root of 3 over the hypotenuse, which is 26. 13 and 26 can be reduced by 13. Lily's at a 1, and that's a 2. So that would be square root of 3 over 2. Cosine alpha. Cosine, I'm standing here. Cosine is adjacent over hypotenuse. If I'm standing here, the side that is adjacent or next to me is 13. The hypotenuse is 26. That will reduce to 1/2. Tangent of alpha. Definition of tangent is opposite over adjacent. If I'm standing at alpha, the side opposite of me is 13 square root of 3. And then adjacent is 13. My 13s cancel to leave square root of 3. So these are your final answers for sine, cosine, and tangent of alpha. Okay, let's move down to 29D, 1 through 6. We have this right triangle. Again, we have theta and alpha. 1 through 3, we want sine, cosine, and tangent of theta. So we're going to stand at theta. So sine of theta, sine is opposite over hypotenuse. And if I'm standing at theta, opposite of me is 3.5 and the hypotenuse is 12.5. We are not going to leave this in this form. You do reduce because it can be reduced by 5, but you do not have decimals and fractions together because a decimal is just another way to write a fraction and vice versa. A fraction is another way to write a decimal. 3.5, that can be written as 3.5. That is a fraction written in decimal form. So you don't leave decimals and fractions together. So you need to get rid of the decimals. Each one has 1 decimal place. So it means I need to multiply by 10. Whatever I do to the numerator, I have to do the denominator. So if I do it to 1, I have to do it to both because it's like I'm multiplying by 1. 10 divided by 10 is 1. So multiplying by 10 moves my decimal place over 1 to the right, and that becomes 35 over 125. Okay, I'm going to reduce that by 5. That becomes 7 over, 25. 7/25. Okay, before I go on to the next one, I want to show you up in your picture. Can I still see the picture? So I want to show you up in your picture to get rid of your decimals in your picture so you don't have to do this every time. When you see decimals in your picture, just go ahead and get rid of the decimals. You see that it has 1 place value, 1 decimal place, so it means you need to multiply every one of these, every number. If you do it to 1, you have to do it to all 3, so it would be like a similar triangle. So this new number would become 35, this new number would become 125, and this new number would become 120. So we're going to be using our blue numbers now throughout the rest of the problem. And then I don't have to get rid of the decimals and working it out. I've already done that. So now we were back at cosine of theta. Remember, I'm standing at cosine right here. So if I'm standing at cosine, I want cosine is adjacent over hypotenuse. If I'm standing at cosine, the side adjacent to me or next to me is 120. And then my hypotenuse is 125. Okay, I need to reduce that, and I know I can reduce by 5. I know that this will be 25. and this is 24. And 24 25ths can't reduce anymore. Tangent of theta. Tangent is opposite over adjacent. If I'm standing at theta, the side opposite of me is 35. And then the side adjacent to me, next to me, is 120. That will reduce by 5 as well. That will be 7/24. So these are your final answers: sine theta, cosine theta, tangent theta. Now we want to do sine, cosine, and tangent of alpha, which means we are no longer standing at theta. We are now standing at alpha. So we want all the sides relative to standing at alpha. Sine, definition doesn't change. Sine is opposite over hypotenuse. If I'm standing at alpha, the side opposite of me is 120. The hypotenuse is 125. That does reduce by 5, 24 over 25. Cosine alpha. I'm standing here. Cosine is adjacent over hypotenuse. If I'm standing here, the side next to me is 35. And the hypotenuse is 125. And that will reduce to 7/25. Tangent theta is opposite over adjacent. If I'm standing here at alpha, the side opposite of me is 120. And the side adjacent to me, right here next to me, is 35. And that reduces to 24/7. That's a 7 down there. So these are your final answers: sine alpha, cosine alpha, tangent alpha.